Hello everyone, I am Professor Rachna Mahule and we are learning about the design and analysis of algorithms. In that we are learning about the greedy methods. In last lecture we have learned about one of the greedy method. We have learned about the algorithm, that is Prim's algorithm, which is used for finding out the minimum spanning tree. Today we are going to learn about the Kruskal's algorithm. That algorithm is again one of the most widely used greedy algorithm, which is again used to find the minimum cost spanning tree. So let's start with the discussion of Kruskal's algorithm. Before starting the algorithm, we must know what is meant by spanning tree. As we have discussed in last lecture, the spanning tree is a tree which is a connected undirected graph. We are knowing it is connected undirected graph that contains no cycle. Means there will not be having any loops in between different vertices here. A spanning tree of graph G is a subgraph. Now here the spanning tree is the subgraph of G, which is actually a tree which contains all the vertices of G. So in the last lecture we have again learned about this. If we are having suppose this graph and this graph is having 4 vertices, so of course the spanning tree is one of the subgraph of this particular graph here. Okay, but here the all the 4 vertices are connected with each other. They will have here, but the number of edges are n minus 1. The spanning tree contains all the vertices, but the number of edges are less there. The actually number of edges are n minus 1. If we are having n vertices here, so of course the number of edges will be n minus 1. So that is what we have the spanning tree here. Now here we have some properties of the spanning tree as we have studied before. That is, the spanning tree with n vertex will have the edges, that is exactly n minus 1 edges will be there. Then it should be a connected graph. The spanning tree should be a connected there. So that is what it should connect all the vertices in the graph. It should be connected. And after that the spanning tree must not have a cycles there. There should not be any cycle in between different vertices. So we have to again maintain all these properties when we are going to study about the Kruskal's algorithm here. So that is what here we have discussed the property. Now we are going to study about the algorithm. So the Kruskal algorithm is to find the minimum cost spanning tree, which uses the greedy approach. The algorithm treats the graph as a forest, and every node it has an individual tree. Now remember here when we are talking about the Kruskal's method, here we will have the forest. Now what is meant by forest? Here we will have multiple what we are going to find out, the edges what we are going to add in the tree, that will not be connected. It will be connected just after the actually when we have when the solution is going on, we will have multiple trees or multiple disjoint trees in the solution, and after that in final solution we are going to get a actual connected tree there. So we are starting with the forest. Now suppose if you are having suppose this graph, right, and here we have suppose these are the edges and they are having the weights on that edges. So each and every edge will have its own weight. So whenever we are going to find out a minimum edge here, it may happen that we are having these two vertices where the first minimum edge is like this and the second minimum edge we are getting like this here in the second two vertices. So these two are nothing but the disjoint trees here, and that is called as forest. The set of this disjoint tree is called as forest here. So in Kruskal's algorithm, we are starting with the forest. Okay, so after that, after the last solution, after the final solution will be a here tree. That tree is the minimum spanning tree which will have n minus 1 edges, and that tree will be the connected tree there. Okay, so that is what here this algorithm treats the graph as a forest, and every node it has an individual tree. We can treating every node as individual tree. Suppose here we are having these four vertices, each and every node is nothing but a individual tree here, and then we are going to combine these two trees, that two vertices here, then we are going to combine different vertices here, then we are going to combine the vertices there. Means here we are going to find out the minimum edge, then we are going to find out multiple disjoint trees, and then we are going to combine all these disjoint trees. And what is our greediness here? We need a minimum spanning tree. The cost of this spanning tree should be very less. It should be minimum. So that is what here we have the Kruskal's algorithm. Here a tree connects to another if only and only if it has the least cost among all available option and does not violate MST property. That is the shortest here. The cost should be a shortest. Minimum spanning tree properties should be maintained here, right? And the cost should be a very less. That is the minimum cost should be there. So that is what here we are having the method. We are starting with the forest. Then here we are going to add the next minimum cost edge to the forest if it is not cause a cycle. Of course, that is the property which is for the minimum spanning tree here, right? And we are going to continue this process until the tree has n minus 1 edges. That is what here the minimum spanning tree properties, again the edges should be n minus 1. So that is what the algorithm method. This is what the general steps what we are going to continue in the Kruskal's algorithm, right? Now here we are having the first example. Here in this example, that example we have already taken in the previous lecture. In Prim's algorithm, we have also used this particular algorithm. Now we are continuing this particular example in the Kruskal's algorithm also. So that is what the algorithm given. The actually example is given. Here we have the graph, and that graph is having here 9 vertices, right? The total number of vertices are n, and here n is equal to 9. Now here what will be the n minus 1? That is the number of edges. When we got the spanning tree, we will have the number of edges, that is equal to 8. It is the property of the algorithm, that is the spanning trees, right? So that is what, if we are having n vertices, we should have n minus 1 edges. So we in this example we are having 9 vertices, and of course we will have 8 edges here. So let's start with the algorithm. Here the first step of this algorithm is given. That is what here the first step is, start with the forest that has no edges. That has no edges means here each and every vertex is nothing but your tree there. Now what we are going to find out? We are going to find out the minimum cost edge there. The minimum cost edge is in between the vertices 1 and 2. That 2 are the disjoint trees here. These are the forest here, and we are going to combine. We are going to union it. right? We are going to combine it by using the age, and that age is having the minimum cost, that is equal to 1. The whole tree, here the whole tree is having the minimum cost age is 1. It is in between 1 and 2. So here 1 is your u and the 2 is v, and we are going to combine it with the cost of the tree here, right? The cost of the age here is 1. We are going to combine it. So here we have two vertices u and v, and the age we are getting here, that is the age is uv here, and the cost of uv is equal to 1. That is the minimum cost. So when we got the minimum cost here, we are going to add it into the spanning tree, right? We are going to add it into the set of age which is having the minimum cost like this. So that is what the first step. Now the second step is what we are going to find out. We are going to find out the minimum cost again. So here we have actually two minimum cost. First is here we are having the minimum cost, the next minimum cost is 2. Here we are also having the next minimum cost is that is equal to 2. We can add any age in our spanning tree, but the condition is given, that condition is there should not be any cycle. So here we are going to start with adding this age, that is from 3 to 9 or 9 to 3. We can call it like this. We can go through 3 to 9 or we can go from 9 to 3 there. So we are going to add the another age which is the minimum. So that is equal to 2, and we are going to add it into the spanning tree. Now again let's find out the minimum cost just age here, and that minimum cost age is here 6 to 7 or 7 to 6. So that is what we are going to add it into the tree, and that is nothing but 7 to 6 here. Now again we are going to find out the minimum cost age. The next minimum cost age is 4, and that is between 3 and 6. So again we are going to add it into the tree there. Now remember, now see here what we are having. We are having this particular as a tree. This is now as a tree. Before that we will have what? See, before that what we are having? We are having 3 disjoint trees here, right? And after that we are going to combine it. We are going to find out the age here which is having the minimum cost, and it should not be there in these 3 sets, right? So it should not be the part of these 3 steps here, these 3 trees here. It should be the another tree. It should form the another tree without any cycle. So that is what here we are going to combine this tree by using the next next age here. So these two, that is what here 9 and 3, what are the disjoint trees, are now connected by using this particular age. So at last we are getting the whole connected spanning tree here, right? Again continuing with this process, we are going to find out again the minimum cost age here, and the minimum cost age we can find like this. Here we have again 4 that is repeated, right? So here it may happen that multiple ages will have the same cost, but we are going to add only that ages which are not actually added in our set and which are not going to create any cycle. So that ages we are going to continue, we are going to add in our spanning tree there. So now here the next minimum cost age is 4, and here we are having 7 and 8. It is in between 7 and 8. So it is added into our spanning tree. Then the less minimum cost is 7, right? And it is between 8 and 9. But here when we add this 7, so at that time, see here, we will have a, if we add this, we will have the cycle, right? So all the graph, the tree is connected, and this connected tree is actually a graph. It is not a tree. When we are having cycles in this, it is called as graph. It is not a tree. Tree never has any cycle. So that is what, when we add this 8 and 9, it is nothing but a cycle. It forms a cycle. So we are going to just discard this particular age. We are not going to add this age in our spanning tree. So again we have to move for the second number, which is minimum, and that that next number is actually again 7. 3 and 4 is not added in our set, so we are going to add it into our tree. So this age will be added in our tree there. Now after that we have the minimum. The minimum is 2 and 3. Again here we are having the minimum, that is 1 and 8. But we are not going to add this one. This 8 is there and this 8 is there. Why we are going to add 2 and 3, the age between 2 and 3, why not 1 and 8? But because if we add 1 and 8, here we will have, after adding 8, now see, here we are going to add first 8, right? So 8 is added, then the next 8 is 1, between 1 and 8, right? So 1 and 8, when we connect this, here we will have a cycle. You can see here, we will have this cycle, right? So this whole is creating a cycle. So that 8 should not be added in this particular tree. So again we are going for the next minimum, and the next minimum is between 4 and 5, and we are going to add it into the tree. Now see here, all the vertices are there in the tree. So whenever we are going to start with the Kruskal's algorithm, always remember that you have to just write down all these particular vertices here. First step is write down all the vertices on their places, and then you are going to find out the actual minimum age here, minimum cost age here. So that is what first, then second, then here we have 4, second, then 4 and 4, we are going like this. So let's start with this. Always start with the vertices, and then you are going to add each and every age which is minimum, which is having the cost minimum, into our tree. But remember, there should not be any cycle. So this is what our last spanning tree. And what is the cost of the spanning tree? That will be here addition of all these ages cost. So that is what the total cost of this spanning tree. So that is what the Kruskal's algorithm. Now remember, in this algorithm, what actually we are doing? Here the first step is to find out the minimum. So we can go for creating a ages. We are going to place the ages in their increasing order. For example, here we have 9 vertices, and here we are having all these ages. We are going to write down all the ages in the increasing order, right? When we write down all these in increasing order, we can easily add it in our graph. So 1 is minimum, it is between 1 and 2, we are going to add it in between this, okay? After that, the second minimum age is what? The second minimum age is 9 and 3 here, right? Between 9 and 3, we are going to add it into our graph. The next is 6 to 7, we are going to add it into graph. So 3 are added here. Then next is 7 to 8, right? We are going to add it here. Now after that, there is 6 and 3, we are going to add it there. right? Now after that we have 3 and 4, right? So we are going to add it between this 3 and 4, right? After that we have 9 and 8. So 9 and 8 is having the cost 7, but when we add this it forms the cycle, so we are not adding this. So although it is having the minimum cost than this 2 and 3, we are going to add the next number, that is nothing but 2 and 3. We are going to add this, but it is having the value is equal to 8. Minimum is 7, but we are not going to add this, although it is having a less cost there. Why? Because it creates a cycle there. So that is what we are thinking. In the Kruskal's algorithm, we are going to just sort out all the minimum ages there, minimum cost ages there, and one by one we are going to add in the spanning tree. And after that, as a result, what we are getting? We are getting the minimum cost spanning tree, because the very first edges what we are getting in having the minimum cost at the front, and the maximum cost edges will be at the end. So we are going to cover all the edges which are in the starting. So we will get the n minus 1 edges in previous steps again. So that is what the concept here. So that is what the Kruskal's algorithm. Now here we are having the early form of minimum cost spanning tree. So here we have the algorithm for the Kruskal's algorithm. How it is going to find out the minimum cost. So here first tree is equal to 0. We don't have any value in t, right? Now after that, here we will go for the algorithm while t has less than n minus 1 edges, because our limit of the spanning tree edges, number of edges there is n minus 1. So we are going to continue until we got n minus 1 values there in the tree, right? And here we have e is not equal to 0. So we are going up to the last edge here, but the condition is we have to reach n minus 1. When we reach n minus 1 we will end, and here if we have already traced all the edges, then we will stop here. Now after that, here what we are going to do, up to the n minus 1 edges, here we are going to choose an edge that is having the vertex u, v and w from E. E is nothing but the set of edges here, and we are going to find out the lowest cost edge. Now when we find out the lowest cost edge, we are going to delete it from E. So of course one edge will be deleted from the E. So next time when we go for E, we will have the next different edges there. So this particular edge what we have already used as a minimum, it will be deleted from E. Now if if V and W does not create a cycle, then we are going to add it into tree, right? Or else if it creates the cycle, we are going to discard it, right? So here we are going for each and every edge there. If it is not creating a cycle, we are going to add it into the tree, otherwise we are going to discard it, and we are initially choosing the lowest cost here, right? So that is what here we have the actual algorithm. Now here the algorithm is having two different functions. Now see, the two different functions are find and union. Now here what is meant by find and what is meant by union? Of course I have already told you that all the vertices are actually called as forest here. Means there is the disjoint set of trees there, and we are going to join it. So here what we need, we have to find out the actual tree there, and then we are going to combine that trees here. So the union ij is nothing but where I and j are the roots of trees. where I is not equal to j, we are going to make a parent. See, the parent may be I or the parent may be j. We are going to add two disjoint trees here. Subtrees are there and we are going to join that subtrees. Now what is to find here? Here we are again going to find the root. That tree is containing the element I here. Now see, integer I and j is there. If I is equal to j, means here we are having a single parent, right? So when we have the single parent, here we are going to just add it in as a parent node and then we are going to return. Now see what it is happening, how it is happening. Here we are having the tree, that is 1, 2 and 3. First node, second node and third node we have added into the tree. Now here we found out that there is another disjoint tree which is having 4, 5 and 6. Now here the two that the values we are having I and j here. That if both are equal means both are having a single root, means what? It is a parent, right? The parent may be I or the parent may be j, but it is not happening here, so we have to join it, right? So how we are going to join it? We have to perform the union here, and because here I is not equal to j, right? So we are going to add these trees in a single tree and we are going to create here a tree from these two subtrees, right? So here we have to check the actual parent of the parent of your subtrees there. That is what here we are going to find out all the trees here, and then we are going to join it by using the union method. Now here we have the minimum spanning tree, Kruskal's algorithm. Now in that algorithm we will have different variables. Here in algorithm we have E, that E is nothing but the set of edges, G is graph here, and the cost is nothing but the cost of the edges. Now after that we are having N. N is nothing but the number of vertices, and tree is actually the spanning tree. What we are going to create at the last, and at the last we will have the T is having the number of vertices, that is n minus 1. Number of edges that is equal to n minus 1. So here what we are going to construct, what is the first step? Here we are going to construct the heap. Now actually we are going to construct the heap tree here, and that heap tree is min heap. Here we have to use the min heap. Now what is min heap here? Suppose here it is a tree which is having like the structure like this one. The heap tree is having the two vertices only, two childs for a single parent, right? So here what is min heap? In min heap the very first, the root of the tree will be a minimum value. Here the minimum value will be the root, and all the there is a property of min heap that the root or the parent will have the minimum value and the child will have the maximum value, and the last one child will have the maximum value in your graph or in your tree. So that is what here we are going to find out the min heap here. So whenever we are going to when we are going to remove the minimum cost age, at that time we have to remove here the root of the tree. In heap sort, what we are going to do? We are going to just remove the root from the tree, that is sorting. In sorting, if we want to sort this tree here, at that time we have to choose the root. and actually the root is minimum. So here the first value what we are getting is the first minimum, right? After that, when we remove this particular root from this heap, so we have to replace it. So that is what the heapify, where we are having the actual root and that root will be removed from the heap, and after that it will be replaced by the last vertex or the last value in your tree. What is that tree will be there? The last value will be replaced by this particular place here, and after that that particular value will be going for a proper place in the tree. We have to adjust that particular value according to property of the min heap there. So again we are going to maintain that root. So the next one will be having the value will be the minimum value, which is the next minimum value in the heap there. So always when we are going to heapify, heapify means the adjustment of the tree there, adjustment of the main heap there, that is called as heapify here. So always we are going to remove the root, that is the minimum value, and after that we are going to replace it with the last value in the heap, and after that again we are going to adjust it at their proper position. Again we are going to remove the root there, then the last value we are going to again adjust there, and then again we are going to adjust in the actual position. So that is what the heapify. So we are always getting the root as a minimum value. So that is what the heapify here. Now in that Kruskal's algorithm, what is given here, we are going to calculate always the value, that is we are going up to the last vertex. When we got the last minimum value there, or the value is equal to n minus 1, the age of number of edges will be n minus 1. At that time we will stop our algorithm. So here we are going to find out the minimum cost age, then we are going to delete that age from the set of edges there, then we are going to adjust the value, adjust the root there in the heap, and then here again we are going to union, we are going to just get a union. So here we are going to find out the actual minimum cost edge there, then we are going to connect all the disjoint trees there, and here we are going to find out the minimum spanning tree. So that is what here we have the Kruskal's algorithm, and if there is no no spanning tree, we are going to return a minimum cost, right? So that is what, if the n is not equal to n minus 1, we are going to write the no spanning tree, and else we are going for the mean cost there, right? So we are going up to n minus 1 edges there. So that is what the Kruskal's algorithm. So that is what one of the greedy method use here, and the results of the spanning trees, the result of the Prim's algorithm and the Kruskal's algorithm are generally same algorithm, are same there. The values will be the same values there, because both are the applications of the minimum spanning tree here. So that is for today. In next lecture we are going to learn about the another algorithm, that is the shortest path algorithm. This cross algorithm we are going to continue in next lecture. So for today, that is what the Kruskal's algorithm. Thank you.